Yeah, thank you everybody for showing this morning. I appreciate everyone showing up, and we're going to be talking a little bit about the Ansys forming. I know that you know what, Jeannie, if you can see others coming into the room, if you're able to accept those, are that'd be much appreciated. We'd be able to
Okay,
do that for me,
I'll
Jeannie.
try.
Okay, thank you. Yeah, I think a lot of you know me. My name is Joe Ham. I've been in the industry now for, well, geez, well over 20 years, and I began actually as a manufacturer representative back in 2002, and of course you probably know me selling the Visi software as well as FTI as well as Dynaform back in the day. And it wasn't until 2007 where I found a home at FTI and Hexagon. During that time, well known the products and services throughout the industry, and it wasn't until this year that I formulated a company called AutoStamp, which is that I primarily took my relationships that I knew that the industry was looking for, and how to actually streamline the software industry to meet companies' needs. And I found that in estimation, design, manufacturing, and today that we're going to talk a little bit about, which is the analysis. And that brings me to the Ansys. Um, and so today we're going to actually focus not only on the ease of use of the software that Jeannie will show us, but we're going to talk a little bit about the trim line, the LS Dyna solver and the outputs, how to set up a draw, trim, flanging, spring back analysis. And you'll notice that what makes it kind of unique is because Ansys um, purchased the LS Dyna back in 2019. The software was actually being manufactured by the Livermore Software Technology Company back in 2017. So they were already putting this together. And in fact, if I may ask that we mute our phones, that'd be great, just so that we don't have any interruptions for others. But it's kind of, in fact, I was just telling Jeannie, it's kind of a true paradigm how things are occurring in the industry with the incremental technology of today. We look back in the days of when LS Dyna was being put into a lot of different programs, and not to name any companies, but they've now, after the purchase of the LS Dyna back in 2019 through Ansys, they are now pretty much selecting who's going to be a partner or a vendor of that software because of the accuracy of what it produces as the outcome. But they finished that program. Ansys did with through the purchase of the LS Dyna solver, and it was released back in 2021. And now, with the paradigm of these companies coming together, there only truly seems to be one front runner, and now we're going after that particular front runner with the quality of speed, accuracy, ease of use, and that's kind of where which is kind of unique in that one thing that they do have is that they're half the cost of the competitor, and I think it's just due to the how big the Ansys of the company is. It's a $32 billion company, and they focus a lot in on their technologies and evolving certain areas. And one of them right now is focused big on forming, because this is a market that's being led by really one company, and they're gonna, I think, own the market here very shortly. So, as we go in here, I want to introduce Jeanne He. Jeanne He has actually worked for the industry for over 30 years. Not to give away her age, but she's been employed by ETA through 94 to 99, and also has been a contractor with the using the LS Dyna, focused on stamping simulation, product manager for ETA and Dynaform, responsibility for software design, development, training, support, and marketing. And now that she's a LSTC distributor, and currently as a distributor for Ansys, I welcome Jeanne to our webinar. And just before I turn everything over to her, I just want to kind of give some quick house rules. If we can, we'll be again recording this session. If there's any questions, I'd like to have everyone just kind of put those in the chat area until the end of the meeting. And then the last 15 minutes, I think we're going to open everything up and have Jeanne answer a lot of questions. But if there's a quick question as she's going through the demonstration, hopefully she'll be able to hear or see that note come in, and she can address those questions while she's directly in that area. But if not, she may have to go back to it in the last 15 minutes of our session. And again, I do ask that everyone mute their phones, but I think I can probably monitor that as we go through the demonstration. So with all that said, I want to introduce Jeanne He. Jeanne?
Thank you. Thank you for the introduction. And thank you everybody for spending time this morning to watch my demo. I'll try to do a good job, but sometimes maybe a little bit glitch, but here is what I'm going to do. I prepare 3 demos. The first one is going to be formability. Some of you probably already see this example, but I will try to go in depth for cover more post-processing process and move to trimline for this part also. Second one is also crash forming. So we're going to cover gravity loading, formability spin back, and then the trimline development. And this one does have the inner trimline development and the outer one. That's the second one. We probably will spend a lot more time on this one. Last one is multi-stage. I'm going to dive more in detail on the formability setup options. So we'll set up, this is actually many stages. I picked 2 stages to show you. And then in between, I like to try and run everything live instead just pull up the post processor for the result. When I run the result, if it's a little bit long, I'm going to come back to those PowerPoint and go over this standard marketing pages on the PowerPoint. So with that, I'm going to start with the first demo. This is the interface. We start from a new project. Right here, you can specify the project name. I'm going to give a name, test 1. And here you can select code for stamping or hot stamping. And also unit system, we only support one set now, one set system right now. And then this will bring you to this we call process page. On the process page, you can select the material flow direction and then also select what kind of run you like to have, fast run, accurate or very accurate. Very accurate normally used for spin back analysis, or you can have your own setup imported. And most of the time you will go to this page. This is where you specify how many stations you have. So this first demo, we only have 1 stage, so I leave that there. I'm going to start import. Let's import a blank outline first. So my first demo is here, blank line. And then with the blank line, we can define the blank. We can go to blank and say select and define blank. We can define it by curve or by mesh. This time we have the curve, so we can pick the curve, say set, and then we can mesh it. So mesh, we have the option of mesh with different mesh. If you look at this mesh, it's really too large. We have the mesh did not cover the shape. In that case, you can always go to this option, say, okay, let's set up this mesh smaller. Let's go for 8. Still too big. We can go even smaller. 6, this looks good. So I'm going to stop at 6. And then for material, you can select material. You can select from the library, or you can import from your own library system by importing the file. This case, I'm going to just pick a material from here. Okay, so this is the material information. Most material, they don't have the FLD information. In that case, you can, without FLD information, you will not have FLD plot in the post processor. You can always add them. So you can go back to this material menu, and then select weight for the FLD calculation, and then give the material information. I think this material was 2 mil, 2 mil. And then put in the N value. And now you have the FLT information. Apply. And then that's where you put the material thickness and then update. Okay, and then next step, we import all the tools. So I'm going to import, in this case, I have the, I believe it's the S step file. So I have the upper tool, surface, and then this is enough. So we can just go define die. So die is all the surface displayed here. Apply. So once you select apply, the program matched it. If you want to see the mesh, you can see it here. Okay, and the next step, we select binder. So select binder. Binder is really just this surface. So I'm just going to say binder. And then punch. Punch is also the displayed surface except this binder surface. So I can say select all the displayed surface, exclude this one, exclude the apply. And then one more thing we had to specify is this red gear basically tell the program this tooling surface you provide is already offsetted, or we need to offset inside the program. So select that and then select, and then tell the program this surface you provided is upper tool surface or lower tool surface. For this case, it's the upper tool surface. And then the program will automatically, invisibly mesh the part. Offset the part. So you're all done here. So that's all you need to do. Now I'm going to turn off the surface and then go to position. So the program going to automatically position the tool. Automatic position basically clear from the contact of the blank. So you can tell die moved up, blank moved up, and binder moved up, and punch stayed. And there you can run the animation, say preview the information basically. And then with that done, you're all set. You can go to runner. When you go to runner, the program is ready to send everything to the solver. And then you can select the draw stage and then start. So this will not take very long. Once it starts, you will see this. There will be a clock here showing you the program is running. Underneath here, and you can see the screen. If you run Dyna with other software, you can see this. This is the same message you have. So this will run a couple minutes. When this is running, I'm going to pull up the PowerPoint. So this PowerPoint is from Ansys Form team, the development team. Basically, they shows all their plans. The key thing for Ansys Form is it's integrated for the simulation analysis. It means the solver and the interface is from the same group. So their goal is make the GUI, the interface, graphic user interface, intuitive, easy to set up for complicated forming process, and also provide accurate and consistent result. And again, next page, this is talk about the keyword is fully integrated platform. And then they're focusing on process-based flow and intuitive graphic, dedicated post-processor, and accurate, efficient. This is one of their animation shows the steps. So this shows the post-process. This is post-processing several operations. We have operation draw, and then flanging. Also, they can draw the part, not in draw position, in the cut position. Trimming process, flanging process. That's the job manager. Yeah, post-processor can easily show all the steps throughout the stages. Okay, I think my simulation is done. Yeah, so 100%. This only take 1 minute, less than 2 minutes. Then we can go to post-process. Here you can easily see the animation. And right here, I'd like to show you a little bit more functions here. So for animation, not only we can look at the thinning, thickness, we also have this called edge stretching. Sometimes the edge split is hard to detect. You couldn't see from FLT, but you can see sometimes there is a criteria how much the edge stretching can handle. So that's edge stretching. The other function very interesting for you guys is this circle grid analysis. Circle grid analysis allow you to put in the circle on your part. We normally go from the beginning stage, apply that circle, and then go to the final stage. And right here you have those options. It shows your string and also show the contour. And right here you can tell, I wonder why this part shouldn't be split. Anyway, but you can see where you have the high stretch. Okay, I have a little bit problem here. This material, probably the thickness I gave it wrong. So I'm going to go back. This is a nice part about Ansys Form. If something wrong, you can just easily go back to the preprocessor definition and change the things you did wrong, and then go back to the runner and run the analysis. Okay, so this will take another 2 minutes. Joe, do you see any questions in the chat? Or we can take some questions in when I rerun this.
No, I don't.
Yeah,
Currently don't. No, we're question free.
When this is running, I'm going to show you. This is supposed to show the circuit grid analysis. The circuit grid analysis is supposed to show you where you have the very high stretch and also shows you the directions. They show you two directions, major and minor. The major direction is where the circle have the longest diameter direction. The minor is perpendicular to the major. So you can tell this red area, you have major stretch along this direction, and the other direction, you probably have compression, negative minor. So this is a very useful function for a lot of users. Okay, so this is almost done. Yeah, the reason I rerun this is next step, we're going to run trimline analysis for this part. For trimline analysis, you cannot have the severe splitting. So let's check analysis. Okay, so this part, I think I did something wrong. This part not supposed to have split like this. But this shows you all the analysis, formability functionalities. We can also show drawing here. And drawing have several options. You can select the drawing perpendicular to the part, or show the history of your nodes travel. Basically, this node start from here and here. So these are two little bit different options. And you can also tell from which stage you're tracking the drawing. So this is the beginning stage. So this is tracking the drawing from this stage. Let's see the stage we're going to, instead using timing, we can use die, the die travel. Let's see, I like to travel the die, the movement of the edge from 5 mm from home. So the reference frame is 5, and then go to the final. That's the last stage. We have the final stage towards the reference stage. So reference stage in the beginning, and then you can move the reference stage. So that's how you check the drawing. I will have other examples show you how to use the material line. And this is about all the major options here. Okay, so with this demo, we can move to the next step. Next step is the trim line development. So if I import this part, I'm going to go to the final stage and then import the product line. So I have the product line here. So this is the product line, and our final product looks like that. So obviously it's not matching, it's far away from the target shape. If we need to develop this trim line, we have to go through several iterations to adjust the initial blank shape. So to do that, we're going to go back, use this same database. First, we have to go back to process. For trim line development, we have to have a blanking process or trim operation. So I'm going to add another operation, and I'll move this operation before this one and change it to blanking. The reason I move it is the second, now we have two operations. Operation 5, blanking, and operation 10 is the one I already defined. So I only need to define the blanking. So for blanking process, we have to have a blanking operation which has a blank larger than this initial trim line. So I'm going to define this blanking operation. So under operation, we have blanking and draw. Now we're in blanking. For blanking, we need to define which area you're going to keep, basically which side of trim line you're going to keep. So I'm going to pick one node, set keep the inside here, and then the trim line. So our trim line, I think I supposed to define the blank first. So let's go to, for the blanking operation, instead of using the trimmed blank, we use the square blank, and then we trim it. Okay, so let me open this. Okay, so I'm going back to process, add one stage, and move this stage to the beginning, and change it to blanking. Okay, and then redefine the blank. So define blank. Now I'm going to use a designed blank shape. So I'm going to design one blank like this. Okay. And then I'll say this will be my outline. Click on that, say set. And then again, mesh it. So I can use, this mesh is good enough. So I'm going to use that. And then under process, we have blanking. Define it's called a seed node. Seed node means tell the program which side of the sheet you're going to keep. And then the trim line. So our trim line is our initial blank line, which is, let me see, right here. Okay, and then I'm going to fix this draw. So draw is the same one. I think what we did wrong is we're going to offset, give more clearance between the tools, the upper tool and the lower tool. Okay, now we can run the job again. We go runner, and then select that. Default, we always have 4 CPU. So blanking is basically a trim operation, doesn't take long. And draw, we do have to rerun the draw. Okay, so blanking already finished. Now the program will automatically move to the draw analysis. So I'm going to pull up this PowerPoint and continue this. I think we're at yeah, we were here. Post-processing. We will go over this function for the multi-stage, in the multi-stage demo. This is the FLD drawing, and we can mark all the drawing. Multiple window. You can load multiple projects same time. And that's it. Ansys Form also support all these CAD format. I normally use IGES or STEP. STEP tend to be much more clean than IGES. That's my experience. We also have this stoning function for large panel. You can specify a stone size and then check if you have any high or low area for Class A surface. Ansys also worked on improving the solver, mainly the solver speed, how to improve the speed for the calculation, run shorter, and also keep the accuracy. So that's there are a lot of work put into this. It's called adaptivity, smart adaptivity. So we basically have 4 sessions in the one interface, which is pre-processing, job submission, and solver and post-processing. And we do have a database called DBX, save all the information in the model setup. And if you have any issue, the DBX will save all the surface or the meshing for you. All right, so we have blanking and draw. And then now we finished the draw analysis. We could have set up the trim line right here. To set up trim line, you go to process and then go to advanced and go to trim line development. This is really means this is really enabled after you have the blanking or trim operation inside your simulation. Otherwise, you couldn't use trim line analysis. And then we can go to advanced. When you go to advanced, they are going to show you, they see a trim line here, which is I'm going to turn up here, you can see, which is our trim line right here. And also the program will say, would you like to develop this? I'm going to select that, said, yes, I like to develop this. And then the program will say, what's the target line? So the target line, we have to give the target line to which from our product line. So I'm going to import the product line. And this product line is, we call it solid. It's a solid. We can only handle we call shell mesh, one layer, not the solid layer. So we have to create the middle surface or middle line for this. And I already have this, so I'm going to bring in, I think this one, target line. You can tell the target line is right in between these two. If I turn off the product line, you can see the target line. Okay, so we just need to select the target line as this. This one is easy, only one of them. Next one, you will see there are many more lines for development. And then you can select the tolerance. I'm going to leave it default and then run. So I'm going to go to the runner. Right here, I already have the result for blanking and the draw. I'm going to just select trim line and start. So trimline development will go through iterations. We will have initial compare with the target line, and the program will automatically adjust the blanking line, rerun the blanking, rerun the draw, and then wait till it meets the target. I think I was going to run this alive, but I'm a little behind schedule. So I'm going to pull up the result file. I have one result file. I'm going to open the result file. So the result file will look like this. It basically shows you each iteration, where is your target. So the first, this is the initial one. We see we only have 14% of the line is within tolerance. And then we can check iteration one, this already 94% within the tolerance. So once it's inside the tolerance, it will stop. So 94%, and then this one I run more iterations till it's 100%. So iteration 3 already 100% match. And once it matches, it stopped. So iteration 4, we don't have anything. Okay, so that's the trimline analysis. That's my first demo. I'm going to move to the second demo. So second demo is a crash form, but there are a lot of trim lines. I'm going to get out here. So when the job is still running, if you need to stop it, you always stop it properly. Go to here and then select stop. Okay, this is finished. It's here. So select this job running and stop it properly. Is everybody okay? Joe, can you check? Is everyone okay?
Yeah, we're looking good.
Okay.
Does anyone have any audio issues or video issues? Looks like we're good so far.
Okay.
Great.
Good. I'm going to move to the second demo. Second demo is focused on, I'm going to show you, the second demo is crash form, but with a lot of trim line. So we have it's a high stream material, and also it's relatively large material. We have a large part, we have to run a gravity also. Gravity, spring back, and then trim line analysis. So I'm going to start with this default path, and then I'll start the import. It's only one stage, so I'm going to start import files, use the default one stage. Let's go to demo 2. Yes, it's that file. So I'm going to bring in the blank first. So that's the blank. Okay, with that blank, we can start mesh the blank, select the blank, and this one have lots of lines. We are going to pick this as the outer line, and then we pick all the inner as the inner line. So I'm going to pick. You can continue pick them or grab them by the window and then say set. So that's all the inner line. And then I'm going to select mesh them. This is a very small cut hole, so the default element size will be too big. I'm going to try, let's try and make it 6, probably too large. We can see if we use it too large, it's going to cut it off. See that cut it off? There's another trick you can do is, we can still use 6, but I select this adaptive mesh. See that? Adaptive mesh with 2 levels and apply. And you can see the program will adapt the mesh in those trim area. There. Okay, and then you can have small mesh cover those detail area and then large mesh in the flat area. The reason we do that is the speed. You can have the simulation faster if you have a larger mesh. Okay, and then material, this is a dual phase DP600. So I'm going to pick dual phase DP600, open. This one have the FLT curve, good. So I'm going to select that. And the material thickness is 1.4. And this one doesn't have any constraint, but it does have a guide pin here. So I'm going to, next step, I'm going to import all the tool. So tool surface, we have the upper tool and the lower tool. So I have the upper. Then I'll import the lower. Oh, I have to import the surface. So I have upper tool, lower tool, and then the guide pin also has a separate surface here. You can see the guide pin surface here. Once we have the surface, we can go to operation. This is a crash form, so I only need 2 tools. So I'm going to delete the binder. Define the die, select. We can select by window, by cursor, also by part right here. By part, I can just pick the upper tool surface, apply, and then same thing for the lower tool. Pick by part, lower tool, apply, and then tell the program this one already offset, and then define the guide. So we go to guide pin. Right here, I already have the guide pin surface. I'm going to turn off other surface. And then right here, click here, say pick existing entity. So I'm going to pick this surface, which is right here. Okay, another one. It's on the other side. And then you're done. Not completely done yet. This is a large part, so if you look from the side, obviously gravity will change the shape before we draw. So we need to select gravity loading here. And there are more options for gravity loading. Most time you don't have to. Sometimes you can select which tool the gravity loading going to going to be set on, and also select which orientation you like the curve to happen. You can have all these options. In this case, we will also run spring back. So I'm going to pick spring back. And then we can go to position. Okay, this is, you have trouble with the pair tool. Yes, we only have 2 tools, so only 1 stage needed, which is the upper die close with the lower die. So I'm going to close this stage, delete this stage, so only crash form. Now position, and then we can check the tool motion. It's very straightforward, just the upper die close down. And then we can run the job. Run. So the program will start run gravity loading first, and then running the draw analysis. So when you run gravity loading, you can look at the information here. All this shows the energy change. These two du and u and ei over e, this is the energy norm. Basically the current energy versus the initial energy. And then the displacement versus is a normalized displacement. This number is supposed to go down. If this number goes up, means you have some issues. You couldn't get conversion result. So I think the time is running short. I was going to run through this, show you, but I think I'm going to pull up my result file, which is my backup line. So I'm going to open this result is here. So I set 2 runs for this part. One is basically grab loading and the spring back. The other one is the trim line analysis. Right now in Ansys Form, trim line analysis cannot mix with spring back or all the other simulation as one database. So we have 3 stages: gravity and draw and spring back. So I'm going to show gravity first. So this part does drop. And then if you like to see how much it dropped, you can go to contour. Right under contour, this is called nodal value, NDV nodal value. Under nodal value, you can check this result displacement. So we do have gravity down 25 millimeters. So it dropped a lot. And then we can check the draw analysis. Draw is just a crash form, so not much change. You can check the thickness change. There's some thickening and some thinning. So I like to reverse color to make the red color as thinning and blue color as thickening. So you can check the thickening is about 47%. Thinning is not 47, basically 1.4. We can check the thinning percentage. So 8% thinning and 5% thickening. Okay, and then now we can check spring back. This part of spring back is pretty high. We can check the amount. I normally use the same nodal value result. So we have 1/2 inch spring back, this area. Both ends didn't move too much, a little bit, but the center side spring back down like this. Okay, so let's move to trim line. This part, we do have to develop the trim line. And then for trim line, not only we need to develop both sides, we also need to develop all the center area. So trim line definition is definitely more tedious. I'm going to show you how to define that. Joe, do we have time?
Yeah, looks like we have no. In fact, let's just take a pause real quick and ask, is there any questions on anything we've seen so far from anybody? We can leave this open real quick. And if we have no questions, we can roll right into the trim line because I think that's now here's where the excitement begins.
Yeah. Hey, Joe, it's Mohammed here. I just
Yes.
have a question to Jenny. Hey, Jenny, how are we doing?
Hi, Mohammed, good. How are you?
Not bad, Jenny, not bad. Just want to have a question about the spring back. Do you have a spring back compensation, same as what you have in LS Dyna?
Good question. Springback compensation, actually beta version already out. It's right here under, see that post process, not post process, advanced, right here.
Okay.
I see the first version. The first version, they claim they can compensate the cavity, not the binder, which is, most cases we need to compensate the binder, like this case.
Binder, yeah.
Yeah, so I'm not sure how useful that version is. Yeah, but the beta version is out. I think once I feel comfortable, I think I'll show you guys. Right now, no, but it is on the top list of the developers in LCC now.
Okay. And my second question is, I believe you answered that during your presentation. So everything based on just single surfaces, right? It's
Yes.
not, you cannot do like a solid.
Not really. In the solid, you need to. We treat solid as a shell. We just measure the whole shell.
I see what you said. Okay.
Okay, I mean, there's some drawbacks and there's some pluses to that, but it's not only the educational curve, but the runtime is quite a bit astronomical. But I think it's something that Ansys is going to steer away from at this time on the forming aspect, because they get the accuracy as well as the quickness with the solver.
Okay.
Okay.
Thank you, guys.
I was going to define this, but we definitely run out of time for that. So for this one, I'm going to show you the already set up the case. We will have a lot of, remember in the blanking, we have all the lines. All these lines will show up in the trim line development as a list here. So if you click, you can see which one is which. So this first one is the blue one is the one I have now, and the red line, the one that they mark as B05 line, is target. So you can what you need to do is just provide a target line for each trim line, and then tell the program I need to develop this. We don't need to develop all of them. Look at those. These are on the top, which will be trimmed at the end. So we don't need to develop them. So all these we're going to develop, especially the one on the side. I think these are the. There's one on the right side. We need to match this. And another one is on the left side. I need to match this, but you can match at the end because it's not really one by one match, but it's okay. The program will know. So that's how you see that, how you define it. It's a little bit tedious. You cannot mess up like ask this trim hole match the target line of the other one. Then you will have a weird trim line come out. And the other, also another trick is all the inner lines, all the inner line like this one, you can select this option called AutoShift. What AutoShift does is going to show, we're going to flip directly to that page. So AutoShift basically look for that square and then match it. I think I used it wrong. They're going to use the calculation. Calculation going to calculate the center for the target closed area and the center of where you're at. and look for the center and move them together. So this function, AutoShift, will give you that, and which will make the development faster, especially for the inner trim. So look at the result. We have initially everything is red. We only have 2% matching for this. Just a little bit match here. All the rest areas not matching. And then iteration one. Iteration one, we have pretty much got the side matches, but a little bit off here and it's still off here. And it kind of shows you how much percentage match for each curve. And then we have the next iteration. We have all the 100% match for the inner one. And outside one, 97, because those areas were not really targeted for matching them. So that's how the trim line worked. Now I'm going to move to the last demo, which is a multi-stage. So for multi-stage, I'm going to close that. Going to just pull up the file. For multi-stage, we basically set up two draw operations. So this one, we have two operations, operation one and operation two. They're in different place, so they have one page moved. The only thing special is when you set up the second stage, you have to move your blank. So move blank option is right here. You click on the blank and click on locating and click on this, and you say my blank need to move. This is a pitch distance, move negative direction into here. So that's how you set up. The other thing I like to mention in this simulation is the first operation. First operation is very tricky. We have two paths. I'm going to go to position animation. You will see we have an upper pad right here in the center area, upper pad above this, close with the lower pad. So upper pad close, and move very little so you couldn't see. Then the upper die come down close with the lower pad, and then close together. So in the other software, you probably have to measure all the distance and then specify how much this will move, and then. But in Ansys Form, we can easily define as these three stages. The first stage is the upper pad close with the binder, which is the lower tool. And the second stage is die close, the upper die close with the binder. And then the last stage is the die drive both binder to home. And so it's very straightforward setup with this driven by option, driven by die. Okay, and operation 20 is just a standard 3-piece toggle draw. And then we can check the result. We go to analysis. In analysis, when you have multi-stage, you can either just animate for both stages separately, or you can say, I like to see the blank up to the current operation. Then you're supposed to see the whole strip of your part. I'm going to stop here. And then we can also, yes.
Just have a quick. There was a quick question from Jim Bristol. In multi-stage, is there any reason to pitch the part for the different operations versus doing the different operations in the same position?
Just look nicer. Look nicer. You can see the whole strip when you move them around. When you move them open, you set in the same location.
Jim, did that answer your question? I will just. Oh, perfect. Thank you. Carry on, Jeanne. Thank you.
Okay. Yeah, I'm almost there. The only thing I missed is show you how to use this material line. Material line actually is designed for, it's not a trim line, but also it's a tracing line, trace line. It's very useful for spring back actually. Let me see if I can show you guys. So for this one, remember this spring back, the final stage, we have very high deformation. Sometimes I have customers said, you know, I like to see where is my trim line before spring back. No, after spring back. So I'm going to bring in the, I think I should bring in the, wrong one. So this is my target line. Basically, this is the line before spring back. And then if you said, okay, I like to see where this line after the trim back, spring back, you can use this material line, and then you say, I like to select material line. I think I picked the wrong target line. Yeah, pick that material line. And then what it does is follow the material, follow the blank. It follows the blank and then shows you where this material after the spring back. So the only thing is you have to have the mesh there for the program to trace where that line is. If you don't have mesh, they couldn't trace it. So you have the trim line after the blank part, after the spring back. I think I probably confused everybody. Is that clear?
Hmm.
So this function is still very useful. And I think I missed the contact information. So contact information basically shows the contact force between the blank and the tool. So if I'm going to go to contact information, and then this is the draw stage, I'm going to go to the home stage. And then you can see this one is not very good example. We only have contact force here. What happened is this is a Taylor welded blank. The center line is actually a thicker material, but you can see where you have all the high contact forces. And there are also some other hidden function in the newer version is this one, blank tool position check. In this one, you can turn on the blank real thickness. So a program going to show you the actual thickness of your blank. And then with the real thickness showing, you can cut the section and then look at your contact of the tool. So I'm going to go to section cut. I'll put in the top view. Cut one section here. Wrong one. This one, horizontal.
Hey, Judy, we may need to cut you short. I do apologize. You may just have to probably even set up another demonstration maybe in a couple of months to even go over some more features. But but that was a lot of information, and I'm really excited of all that you did for us today. That was fantastic. But I do want to open this up now verbally for those who may have questions and are okay of going past the 10 o'clock hour.
Okay. Sorry about that. I think
No, you did good. That was great. Thank you, Jeannie. I also want to let you know that with with the Ansys product, for those who have questions, sales questions in regards to costing or any type of pricing, I know that this tough point in time that they are offering a end of a quarter under the half promotion. But if there's any sales questions, please, please contact me and I'd love to share that information with you. And like I said, I think this product has a lot to offer. You'll find out that within the industry, being that's changing so much, there's a lot of companies who used to use the LS solver who no longer have the right to do so, or not be able to purchase that directly to accompany your products that maybe you're using that have the LS Dyna. That's something that you'd have to also work with us in order to receive that LS Dyna solver. But let us know if there's any questions on that end. I think let's, if there's no other questions, or am I wrong on that? I want to thank everyone. Yes.
I got one question. It's interesting there. You have the solid there after it's formed. Is there a way to export that out into the other software? Or would it only export the mesh?
Probably only mesh. You might be able to export STL. Let me see. Export. You might be able to export XTL, but I have to check if they export the actual, thickness or just only shell. I can check that. Also, okay, thank you. Also, I'd like you guys to check when you have questions. Sometimes I need to know your version. You always go up here, and then say about, and look for which build is your version. I think some of you might have a very old version. You should have this version, the main version, May 23rd. If not, we will send you the update package.
Great. Is there any other questions?
Just have one question for Jeanne again. Jeanne, can we have more detailed information about doing the flanging operation?
Okay.
Like, if you can send us something like explain how you can go through the flanging.
Okay. Yeah, I have some training material for that. I'll send to you.
Okay, perfect. Thank you.
Thank you, Mohammed.
Great. Well, Jeanne, again, thank you. And thank you everyone for sharing this time with us. And if there's any technical questions or sales questions, please have those directed, and I will contact Jeanne if it's a technical question. Also, we can I'll handle any questions that's related to sales. And I want to thank you all for showing up today, and have a great day, everybody, and take care.
You too,
Thank
Joe.
you.
Thank you, Jeanne. Thank you, Joe.
Thank you.
Thank you.
Thanks.
Thanks.
Thank you.